Today we will look at inverse cosecant. Let's get started. Make sure that you watch the graph of cosecant x before you watch this video. Alright. Now, let's remember what cosecant was. We can write cosecant as cosecant of x. It is simply 1 over sine x. Remember that? Okay, and then we drew the cosecant x before, starting with the sine x. Remember, my sine x is that black one. Here we go. Oops. That black one in here. And then we can draw the red cosecant. Do you see it here? Here. Alright, and so forth. And that's not one-to-one. Again, I need to limit my range in a place where I have a one-to-one function. So I pick negative pi over 2 to pi over 2, where my cosecant is simply that little piece in here. Okay? Alright, so we are going to attempt to draw the reflection of that red curve along y equals x. So let's get started. It's a little bit confusing to see, but remember the red one was like this. I'm kind of coloring it in. Alright. And remember what this point was, okay? And if you look in here, it's going to go down. And so that's at infinity, go up. So we are talking about this going infinity and this going to negative infinity and this going to positive infinity. But these 2 points are important. This is going to be pi over 2 and 1, this one. And this is going to be negative pi over 2 and negative 1. Now we are going to try to draw the reflection. So you need to start with y equals x. Remember that? Y equals x. And we're going to try to attempt so that pi over 2, 1 is going to get reflected to here. Do you see it? And then the vertical asymptote, it's going to reflect as horizontal asymptote. Okay? With the same token, negative pi over 2, negative 1 is going to get reflected as negative 1, negative pi over 2. And the vertical asymptote will become a horizontal asymptote. So you end up with something like this. A little piece like that, and a little piece like that. And this has to be 1 pi over 2. And this has to be negative 1, negative pi over 2. Alright? That is the graph of cosecant inverse. Now, let's look at that. Remember what I limited this thing. My domain is negative infinity to infinity, but my range is, is not. So remember, my range is going to be different. So I limited myself to this area. Do you see it in the red? Negative pi over 2 to pi over 2. So in other words, when I do my inverse cosecant, I need to stay in this area, negative pi over 2 to pi over 2. Does that make sense? Alright, so let's get started. So when I take the cosecant x, my x has to belong to negative infinity to negative 1 and a 1 to infinity. And the degree that you get out as output has to be in this region. But remember, at 0, you have to take the 0 out. Okay, because that is where it blows up. Alright, do you see the blue one? Okay, so the y is going to end up in this region. It's spit it out. And so I need to stay in that little shaded region. So let's do a couple of these things. The other thing you need to remember this identity because the cosecant inverse is not built into your calculator. So remember that cosecant inverse of something is going to be sine inverse of 1 over that something. Okay? So that you can use the sine inverse button and then get the cosecant inverse answer. Alright, so let's look at this example. What will be cosecant inverse of negative rad 2? Okay, now I have to kind of start what cosecant gives me rad 2. Well, I remember that cosecant was pi over 4. Remember, that's from the table that I was supposed to remember. But remember, that one is in the positive area, and I'm supposed to stay in this region. So the only negative place, I know that cosecant sine works just like sine, so it's going to be positive here, negative here, and that means to get the negative answer, I need to have this angle, and this angle is simply negative pi over 4. So make sure that you know how to use that in your calculator. So let's go and let's get cosecant inverse of negative rad 2. So remember what we said? Instead of, since we have no cosecant button, so we are going to go sine inverse of negative rad 2. So it's going to be 1 over rad 2. And that better give me negative pi over 4. Yes, it did.